Hello and welcome to this session that is about patching storage spaces direct successfully. My name is Mikael Nystrom and I work for TruSec. You can visit my blog if you want scripts and tips and tricks. I work as a principal technical architect at TruSec, and I'm a Microsoft Cloud and Data Center Management MVP. I've been working with OS deployment for both clients and servers for many years, and also building Hyper-V based data centers, including hyperconverged infrastructure and storage spaces direct. I work as a trainer, instructor, speaker, and of course, I'm also a consultant. And I do have cars and motorcycles. Now, patching storage spaces direct is a sensitive task. In the beginning of the era of storage spaces direct, we had the opinion that it should be done carefully, and we were right. We have seen bad things happening when customers didn't really understand the impact of patching and updating, restarting, rebooting nodes. What you need to think of is that it needs to be treated like any storage solution, like a SAN. If you have a SAN, you don't restart it just randomly. You really take precautions and you read the README file before it says reboot a node or reconnect or reconfigure. Now, you do need to patch it. We have customers telling us that, well, you know, it was so scary, we're not going to do patching anymore. Well, that's not going to fly. But you don't need to patch every month or every week or whenever the patch is being released. So you do need to patch it. Most of our customers patch either monthly or every month, but they stay like 2 months behind on patches, or they patch maybe 4 times a year. It depends on the configuration, depends on the customer, and depends on how the storage spaces direct cluster is connected to the rest of the network. The customers that patch it only 4 times a year, they usually run it in a fabric, so it is by default isolated from everything else. In that case, you don't need to patch immediately, even if there is a 0-day exploit. We don't really like the idea of being first, at least not for production. So when Microsoft releases a patch, we test that in similar environments that we have, and we play around with it and see what it does contain. That is applicable both for regular standard servers, physical machines, virtual machines, as well as for storage spaces direct cluster. You do need to read and understand. I mean, they released a patch and it's 5 minutes old. There's not even a README file. Installing it at that time is usually a bad idea. So download the information for the file or read it online. Try to figure out what the impact could be, what kind of issues they fix, and so on. You also need to select a method. We're going to get back to that, but there are multiple ways of doing that. And please don't be creative. Patching takes time. I have a customer that runs 2 16-node clusters with 1 petabyte of data on each of them. And patching that takes approximately 2 to 3 days. Meanwhile, don't be creative. Don't firmware upgrade your switches. Don't randomly restart machines. Don't migrate everything. Don't move stuff around. When you patch, and the only thing you need to do and worry about is to make sure that everything works and everything comes up after, and check log files and stuff like that. So if possible, try to put on your boring hat and be boring while you do the patch management. It's usually a really good idea. Now you can pick and choose basically between two methods here. It's cluster aware update in various shapes, and this is applicable for Windows Server 2019. For 16, there's got to be another way. There is also possible to patch Storage Spaces Direct Cluster within System Center Virtual Machine Manager 2019, not the previous one. The previous one actually blocks it. Or you can use just vanilla PowerShell to do this. Now, the difference with PowerShell and Cluster Aware Update is that Cluster Aware Update is it's easy. It is possible to automate. It is controlled, and it's well, it runs as a service, or you run it manually, but it orchestrates everything for you. Using PowerShell, it doesn't. Then you need to be the orchestrator. And we have customers using mainly three methods here. They either use Failover Cluster Manager, or they have started to shift into Windows Admin Center. But we do have a large group of customers that says, well, you know, we're going to build our own patch management engine, and we're going to use PowerShell to do that. And it's fine. There are reasons to do so, and okay, you can do that. But for now, let's do a demo. Okay, so what do we have? Well, let's take the manual approach first. So here's the 2-node cluster. Let's go into the Failover Cluster Manager. And the first thing I want to do is I want to see that everything looks nice. I don't have any weird issues. In this case, I don't have a witness. I should have that since it's a 2-node cluster. I want to see that I don't have any bad cluster events. I want to verify that everything looks good. And I don't have any weird configuration or anything like that. You can manually check things, or you can use PowerShell to do so as well. So it looks good. Let's verify. Sorry, let's actually patch this machine. So the first thing I'm going to do is that I'm going to open PowerShell eyes here. And this is not one huge PowerShell script. It's actually two of them. It's a start and stop maintenance script, and they are written so you can understand what they do. So this is the start maintenance. So what we want to do is this: we want to grab every storage job we have, and we want to verify that we don't have any storage job. As you can see, I don't have that. So we run this block to verify that we don't have any storage job going on. The reason why we don't want to have any storage job is that if we have that, it could be that a disk is in a repair mode and it's trying to regenerate and resynchronize data. If we try to patch a machine or restart a machine at that time, there is a potential loss of data situation, and that is something that I don't want to have. So we don't have any jobs. Cool, then we can stop the cluster node and put it in a drain mode. So we're going to drain the cluster node here. For Server 2019, that doesn't stop disk replication because that's going to still run. Now, I did have a customer that says, well, I tried to put the machine in suspend mode, forcing it to drain, but it didn't work, so I pulled the plug from the server. That was a bad idea. We managed to get the data back, but it took a while. If you can't suspend a node, then there's something wrong, and that wrong needs to be right. Now, if I go here, I should now be able to see that the node is now successfully paused, and that one node is running. If I go to my disks, they are healthy. And they should be, because they still replicate as they should. Now, we're going to put the disks in maintenance mode. And if we can't, we're going to flip them back. And this is just to be 100% sure that everything works. Now, there is another way to do this. I actually have one customer that does this. And what they do is that they make this very secure. Number one is that they turn off all the roles. When they done so, they dismount. They use the takeoff line for every disk, and then they put the pool offline as well. Now, the benefit of doing that is that if you have a 16-node cluster, or even a 10-node cluster, and if you disable all the disks and you disable the pool, then you can patch all the servers at once and restart them in one big let's restart. Because if the pool is offline and the disks are offline and you don't mess with the hardware, there's no risk, because the data doesn't need to be replicated because it's not online, so the disks are safe. And I don't have many. I have, as I told you, I have one customer that does it, but they do that because they think that's going to be faster, and they don't need to be having all the systems online at all times. So they actually do have a window of opportunity and say, hey, we can patch during this hour and we can restart all the servers. And it has been working for them, and they will most likely continue to do so. Now, this is going to be online while we do this. So now everything is in maintenance mode, and if we get the scale unit here, we can see that we have two of them. Let's get that. We should see now that the disks, okay. If I go here, no, if I go to the pool and check the physical disks, you can see that I now have the 3 disks in maintenance mode here. That means that I now can restart this node. Fine, let's restart that. Once we have restarted it, then you stop the maintenance job by resuming the cluster node. And then we disable the storage maintenance mode. And that means that if we run a get storage job, you can now see that we have something in repair. So we're going to run this until we don't have any storage job running anymore. And then you repeat this on the other machine. Now, we use this both for patch management, but sometimes we end up in situations where you need to update an agent or install an agent, and you can't. And it shows up that you have a pending reboot, and you should not have a pending reboot because you didn't do anything. Well, the last time you did something, whatever reported back and says you don't need to restart the machine was slightly incorrect. It did need a reboot, but it wasn't done. So therefore, when you try to install something, it's going to say like something like there's a pending reboot. That means you can't really patch the cluster because you can't install anything and you just need to restart it. So we use these scripts also just for the fact that we need to restart an entire cluster without really patching it or anything like that. I don't have any customers doing that on a regular basis, but I have customers that have talked about it and they have asked if it's possible. And yes, it is. You could just restart an entire cluster just because you want, or just because there is another need that maybe has nothing to do with patch management. Maybe you need to replace a driver. Maybe you need to do something like that. Anyway, we run this on node number 1. Once we don't have any storage jobs, then we can do the same thing on the next node and run the same kind of script again. It is possible to connect all these scripts together, and it's also possible to run Windows Update using PowerShell. Now, there is one little trick with that. And when you run Windows Update and using remote PowerShell, it doesn't work in a remote session the way you think it's going to do. So the easiest way to fix that is to run a remote PowerShell that creates a scheduled task that runs Windows Update. And then you start the scheduled task by using remote PowerShell to start it. Most solutions that work is using that method. It is the way, and the way that the Windows Update agent actually works. So that was the manual approach. Let's check the other approach. Well, here's the other approach. You can use cluster-aware updating. So when you use cluster-aware updating, you connect to the cluster, and the first thing you do is that you analyze the cluster updating readiness. There's two ways to run this. You can either run it as a service that then gets installed on the cluster nodes. And then you can either schedule that or you can run it manually. I usually don't do that. I instead use a third machine. So I start the cluster update from that third machine instead. So that will now be the orchestration machine. But it's possible to configure what's called cluster self-updating options. If you run this through, you can enable, disable, or you can remove it. In this case, I have the cluster self-updating mode, but it's disabled, so it doesn't do that. Once you have that, you can now do a preview of updates for the cluster, and it's going to generate an update preview list. And this is going to tell me the following things: that I do have 3 patches for each server, and in this case, they pretty much look the same way. It's the .NET Framework, it's the Flash player, because they are UI-based or desktop experience, and then we have the definition update. If I want to patch this cluster, then I apply updates to this cluster, and it will take one node at a time and move the roles. In certain scenarios, we have machines that cannot be moved by the cluster update service. In that case, we need to manually move all the resources before we start doing this. And then it becomes tricky to run the cluster-aware updating, because depending on why you cannot move the machines around, it could end up in the only way to fix it is manually. But we have some success with machines that cannot automatically be moved and still using cluster-aware updating by configuring the VMs or the resources so they can only belong to a certain number of a certain set of nodes. So this is rather easy. The third way, what I would call third way, is to use Windows Admin Center. Now, to use Windows Admin Center, you pick up your Hyperconverged Cluster Manager, you go to Updates, and it's going to tell you that it needs to install software. Let it install software. It could fail, and in that case, nothing happens besides you have a spinning donut The most common reason for that is that you do not have delegation set up correctly in Active Directory, so that the cluster aren't able to create the cluster update service, which it needs to do. Once you have that, then you can run the check available updates, and then you see the updates. From time to time, using cluster updating, cluster-aware updating, it doesn't happen that often, but it does happen. One of the nodes doesn't show any patches. That doesn't mean that node doesn't have any patches. It means that the Windows Update agent are either stuck or it's already running and it can't see that, or something like that. In those cases, the only way we have managed to fix it is either to stop and start the Windows Update services. That usually kicks it. And if it doesn't work, then the trick is to restart the node, and then we're back to the PowerShell scripts again. If I want to install these, the only thing I need to do is apply all updates and wait until this is done. And just for the fun of it, since this cluster is not important, we can try to do so. And of course it fails. And it says error. Let's try it again. See if it's done. Yes, it's done. Let's see if it works this time. Nope. Okay, let's try the other tool. Now it says waiting. Scanning for updates. And installing update 2 out of 3. The reason why this failed, now you can see it says installing here and waiting, because it's reading the same information. So this is a preview, and the version of Windows Admin Center is a preview as well. I have tried it on other systems and it has been working. I have no idea why it fails right now, because it's basically doing the same thing as the other system, since it's using cluster-aware update. But this is the way to patch. Now, once you've done this, you are not done. You need to validate that the cluster is still working as expected, which means that you need to validate the cluster. You should validate the cluster every time you do a modification to it, just to verify that everything works as expected. And you should also keep the reports so you can compare the reports with previous reports and see if there is anything that might change or things like that. So do validate the cluster, view the validation reports, and pay extra attention every time you do these kind of updates. Now, if you do firmware updates, because that also might need to be done, clusterware update can't really help you here. So for firmware updates and driver updates, we are back to using some kind of PowerShell script to do that. I do have one customer that have, instead of building one storage spaces direct solution, what they do is that they have 3, and they use 2 of them for full production, and one of them is always standby. And they move around the VM, so they constantly are patching one cluster, but when they are patching it, it's totally empty. And then they move the workload around. It is tedious, it takes time, but that can also be fully automated. So if that's an option, well, then it could be an option for you. Most important thing is that you take this very seriously. I have personally salvaged systems, and it has either been really bad patches, that happens from time to time, or it has been the customer that didn't know exactly how this works. So they do things that they should not. And it's easy to come in as a consultant and say, hey, you did it all wrong, you should do it this way instead. Yes, it's just that if you do that on one machine and you lose, I don't know, data, a couple of gigabyte, then it's really bad. But if you lose a petabyte of data, then it's really, really bad, and that's going to be a really bad week or a year or something like that. So please be careful and think of what you are doing. I hope that this gave you some insight on how to patch these things, and that you don't need to rush just because there's a new patch. You need to, don't be the first, read and understand, select the method, and please do not be creative at the same time you're patching. Now, with that said, have a very nice rest of your day, and please patch carefully. Bye.